camera's not working for some reason.
Yeah.
All right. I guess we'll just have to see if I can share. All right. Good morning. This is a Cosmology discussion group. And today we're going to talk about MacCullagh's theory. And I had sort of got interested in this from um, Vladimir has mentioned this a number of times in his papers, and I didn't really know that much about it. So I thought I'd take a look at it and see what it's about. And so I'm going to talk a little bit about that. MacCullagh's theory. Okay, so is it working? Do you see the presentation?
Maybe it's coming up now. I don't see anything yet.
All right.
An odd thing happened, Harry. Roger sent a request to give permission to record this meeting, but that came to me, so it seemed to think I was the host.
Yeah, it's screwed up. I don't know why. See, I don't have a video. I can't get my video to work.
No, don't know what that is.
I tried starting it. It's turned off my video for some reason. All right. So the MacCullagh ether model, and so the reason I think I mentioned that was because of the paper by Vladimir, in which he says unique properties of ether were discussed by J. MacCullagh in 1846, who proposed a theory of a rotationally elastic medium. Okay, so one of the things is we're going to try to figure out what that means. The potential energy of deformation in such a medium depends only on the rotation of the volume elements and not on their compression or general distortion. The theory produces equations analogous to Maxwell's equations. Okay, that's kind of wonder what that means. Ether with these properties can transmit transverse waves. MacCullagh has this to say about the ether. The constitution of the ether, if it ever would be discovered, will be found to be quite different from anything that we are in the habit of conceiving, though at the same time very simple and very beautiful. An elastic medium composed of points acting on each other in a way supposed by Poisson and others will not answer. So he's proposing a solution to a problem that apparently other people have been working on and not successful. Now, one of the things is that this is before Maxwell. Okay, this is 1846. This is about 10 years before Maxwell's first paper. And I think that I can't remember the name of the paper, but I think that was in 1856. Okay, so the main question I have is this statement: this theory produces equations analogous to Maxwell's equations. Well, that raises some questions for me. Not clear how this is possible, since MacCullagh didn't have the idea of displacement current before Maxwell. So I don't understand how you can have a theory that produces equations analogous to Maxwell's if you don't have displacement current. So that raises a question in my mind. This is really the main issue for me as far as I'm concerned. I don't understand this part. Difficult, and of course, Maxwell's theory is the big issue with Maxwell's theory is we have both displacement current and conduction current in Maxwell's theory. And so what is this displacement current and what's it mean? And I think what we find out is that from the beginning of Maxwell's theory on to the end of the 19th century, this becomes a question. How is displacement? what is conduction current? What is displacement? What do these things mean? I don't think these issues have really been resolved today. I have my own ideas about displacement current, which are not really consistent with the mainstream view. I don't think the mainstream view knows what displacement current is, because they talk about it as being in a capacitor, which Maxwell never said anything about displacement current in a capacitor. It was supposed to be a current in the ether, the displacement of electricity in the ether, in Maxwell's ether. But Maxwell's ether isn't MacCullagh's ether. So that some issues there. Okay, Unziger, and I don't know, I sent out these videos. Unziger, which is kind of a surprise to me, brings up this issue about MacCullagh, which is kind of unusual, since most books don't really even talk about MacCullagh. It's like would appear to me to be that being 1846, I think it was, isn't that 1846? That's 10 years before Maxwell. And so it would seem to me that any discussion of his particular theory would have been superseded by Maxwell's theory. And then, of course, that's superseded by Einstein's, when Einstein says the ether is superfluous, whatever you want to go with that. Okay, so what's the whole point of what MacCullagh is talking about? And that's suggested earlier when I quoted from Vladimir. He says that there's only a rotational. There's only a rotation. So it's an ether that is incompressible and only has elements that rotate. It's not really particularly clear to me what this means, although it's stated over and over again, and there's very little information that I was able to find. But the main point of it is we want an ether that transmits transverse waves and not longitudinal waves. And so based on that criteria, so that's the primary criteria. We want an ether that doesn't transmit longitudinal waves, because they knew at this time from their experimental evidence that they weren't dealing with longitudinal waves, they were dealing with transverse waves. And so that is achieved by having an incompressible ether. Now, I don't know how many people you should have watched at least the first video by Unziger, where he discusses this and somewhat, he has a model where he uses a sponge and he shows the different ways you can stress the sponge, and discusses this point about we don't want longitudinal waves, we only want transverse waves. And so I'm going to move on. We can discuss if you have any questions about this later. Okay, so the only other thing that I could see was Larmor, Joseph Larmor in 1895 took up this issue, and he kind of got into a controversy. And this comes from a letter in Nature. And he says, according to MacCullagh's scheme, its elasticity would consist simply in resistance to absolute rotation. Now, I'm not really sure what that means. If somebody could tell me what that means, I'd be real happy about it. So that an element of volume of the medium is taken to have relations to directions in space of the same general type as the axis of a spinning gyrostat actually possesses. Gyrostat, we would use the term gyroscope, which is a spinning top, basically. The analysis of the interaction of this inertia and this elasticity forms a dynamical theory of the medium, but the dynamics is not the dynamics of ordinary matter. Well, that doesn't really help us too much, does it? Um, Now, Lord Kelvin has helped us a little bit. He has a mechanical model. Lord Kelvin has actually shown how to make a model. Well, maybe, I'm going to show you the picture representing MacCullagh's medium by means of a cellular structure composed of portions of ordinary matter and spinning motion. That it's still not clear to me what this means. Okay. All right. So I'm going to stop sharing and I'm going to, oh, I think I made a mistake here. So pardon me. And I'm going to show you what the picture is of, okay, can you see this? Can you see this picture?
Yes.
Okay, so this is supposedly Kelvin's um, model, his mechanical model. And I don't really quite understand this picture, but this comes from um, this Lord Kelvin's Theory of Everything webpage. And the more I read of this, the less I understood, to be quite honest with you. But essentially, the picture on Figure 2, which is on the right, these are gyroscopics. They're spinning flywheels, basically. And he's got 4 of them in here. So it looks like he's defining a plane structure that's coupled. Looks like he's got hinges here and on these shafts of these flywheels. And so what his ether appears to be is essentially an ether that resists rotational change like a flywheel would resist rotational change. So in other words, if we have a spinning flywheel, it tends to want to stay in its orientation. And if you try to put a torque on it to move it, to change the orientation of its axis, it resists that. So that seems to be what they mean by the MacCullagh, his absolute rotation, resist absolute rotation. Okay. Oops. Okay. So we're back to the presentation. Everybody see that? Okay, I'm going to finish up here and say I was real puzzled by this until I discovered I was going through a number of books, and we can talk about during the discussion some of the. I was able to find some information in various different books that describe MacCullagh's theory, but it's not very clear. So it's one of these theories, I think, where you have to understand the equations and the mathematics that's involved, which is, I believe, summarized in most of the mathematical descriptions of it. And I confess I couldn't, I'm just not able to understand what they're talking about. This is pretty old theory. Okay, 1846 is kind of hard for me to imagine how his theory can be said to be equivalent to Maxwell's equations, but I found this, and according to Born, this is Born, or you don't have, the camera's not on, so I have a copy of Born's book, Einstein's Theory of Relativity, page 189, and he says, once the problem of longitudinal waves is removed and waves become transverse. Now, we talked about that. Apparently it has to be an incompressible medium which only respond to rotation. So it has resistance to rotation, but it can't be compressed. And such a medium only allows transverse waves. And Bourne says Maxwell's theory is almost identical formally with the ether theory of MacCullagh without repeating its deductions. We can take over most of its deductions. So Bourne is saying in this book that we don't have to go into Maxwell's theory. We can use MacCullagh's theory of the ether. And I think that's what Vladimir is saying in his quotation that we started off with. I think this is kind of where it comes from, or at least this is an example of this idea that this theory, referring to MacCullagh's theory, produces equations analogous to Maxwell's equations. So Bourne says so in his book. He doesn't explain it, and so I'm still kind of mystified as to where the how MacCullagh's theory of 1846 can be analogous to Maxwell's equations. And that's kind of the end of my little introductory talk here. So anybody have any questions or comments about this? My attempt to make sense out of what MacCullagh's ether model is.
Well, I only had a quick look at this, but I thought perhaps MacCullagh hadn't introduced something similar to displacement current, but what had come out of his ideas was a relationship between the curl or the rotation of one field and the rate of change of the other. So in other words, the Faraday or the Ampere laws, expressed in analytical form. I thought that might have come out of MacCullagh's theory. And in that respect, they're analogous to Maxwell's equations.
Yeah. The puzzle I have is if that's the case, then you can only say that he can explain the Faraday law, but not the Ampere law.
This is Vladimir speaking. Can I talk a little bit about it and to say you my understanding of what the MacCullagh, genius physicist, done before Maxwell? It's really his equations, not Maxwell equations should be. Let me remind you that later, instead of electromagnetism, it was introduced gravito-electromagnetism, in my words, gravitomagnetism. Many times I thought about it. And they have the same analogous Maxwell equations, but instead of charge, you have your mass, and that's it. There is no reason to name its Maxwell equations as electrodynamic. It's a gravitomagnetism. You have your mass, you have. On the contrary, we must use not only masses when we are calculating the orbits of planets and all this stuff, but mass currents, all this stuff. That's why analogous only the shape of these equations, but not the meaning of it. That's why, for me, Maxwell equations should be maybe MacCullagh's equations, but meaning of them is if you have your charge, you have electrodynamic. If you have your mass, you have your gravitomagnetism, and that's it, simple like this. The second very important point, we don't have rotation of this volume rotating. There is a rotational potential energy. It means elasticity like rotational. It means that these elements under some force, they can only rotate, but not rotate, to move along the axis of rotation, move a little bit back and forth, like a standard pendulum, but not in the x direction. Rotation, back and forth, that's it. It's not rotation of elements. It's such elasticity energy you have in the medium. Then the very important point about ether. Many times I told you guys, the energy density of this so-named cosmic medium, I named it, it's so low that talking about some solid, some liquid medium, it's no reason at all. Let me remind you that in the volume of our cosmic medium, we have only one proton per 4 cubic meters. Look, what kind of medium we have right now. How we can treat this as a solid state, as a liquid, and all this stuff. It's it's the energy density of it, 20 orders of magnitude less than our air around us. That's why to treat ether like liquid and solid state, no reason at all. That's why I was so happy to open this, genius, to find this genius, to reveal this genius physicist like MacCullagh, who told the truth about this cosmic medium. Don't go along to Poisson and to all this solid state and liquid state, physics. It's a special cosmic medium, very rare, very, unique. That's why I tried you to it. I didn't do it in my papers because, I wanted only to use his idea. And his idea is a combination of electromagnetism, gravitomagnetism. Really, it is his equations, not Maxwell equation. And what is important, even from university, I remember the first paper of Maxwell equations, and you use some rotating elements. He used this idea. Maybe he knew MacCullagh because, as you told me, it was only 10 years later than MacCullagh developed his theory. Maybe, but I didn't see any reference from Maxwell to him. I don't know, is it really or not? That's why, guys, I'm so happy that 180 years ago, it was the new for me, it was a new for me genius physicist, and we forgot about him at all. Nobody mentioned in universities, in any other papers. By the way, Harry, as usually, you're doing deep investigation of this theory, and I didn't know about this Maxwell's or Lord Kelvin or Alexander Unziker approach to this idea. Because always I try to start from the beginning. MacCullagh was the beginning of the story, and I stopped myself because, for me, the most important is ideas of the people. I recovered this idea and I wanted to share with you and with everybody these genius physicists. We forgot about them or we didn't know about them. That's it, simple like this. That's why if you have any questions, I told you already, I tried to answer all your questions about this theory. Gravitomagnetism is not rotation, but some kind of pendulum, but rotational pendulum in our ether. And ether, it's a very rare medium, cosmic medium, I meant. That's why don't treat it as our standard objects around us. Even air, water, and all this stuff, it doesn't work for cosmic medium. It should be different approach, as MacCullagh told 180 years ago.
Okay. So I'm still not really sure whether you're assuming that this MacCullagh's ether model is an ether that you're assuming in your cosmology, or whether I'm not sure I understand how this ether concept of MacCullagh fits into your model. That's really kind of what my confusion is about.
It's not my model. As I told you, gravitomagnetism was 120 years ago. That's why, I don't pretend that I use it. It's for me the most important is this so-named ether, cosmic medium, can transmit, this our standard, transverse waves. And that's simple like this. For me, the most important is idea. An idea that you can because our standard ether made of solid state, sometimes liquid. It might be only longitudinal waves. And as for transverse waves, it was developed and was opened even before MacCullagh. It was much before. That's why that we have two polarizations of our waves. It's well-known result, experimental result. They had it before all these theories, but unfortunately nobody could explain how it works. That's why the most important achievement of this theory to have to cancel, to reject this problem with longitudinal waves. And for me, it's the same story. I'm so happy that it was rejected. Yes, you don't have any problems with longitudinal waves. That's it. You have your transverse waves.
Okay,
That's
so
why
the
for me,
main,
the most important is that you can work with cosmic medium based on MacCullagh's equations and his idea about this rotational elasticity. It's elasticity, it's not rotation, it's elasticity rotation.
right, that's a little bit unfamiliar concept. That's kind of really the point I'm making.
Yeah, you're absolutely right. Thank you very much for opening for me this other scientists. I didn't do this, very interesting investigation of this theory. I found the beginning. I was happy with him. I put into my model only as an explanation of transverse waves, and that's it. Simple
Oh,
as
I
this,
see. Okay, I
because
got
I
you.
opened all the issues of physics in my model, and it's impossible to do deep investigation for each point as you done today in your presentation.
Okay, so the main point is, and I guess this is clear. The main issue is to make the um, theory agree with the experiments, and we're talking about optics. Um, the waves have to be transverse, and so if you have a model of the ether, you have to have an ether model that produces transverse waves. And so then the issue becomes what properties of an ether medium are required in order to have transverse waves. And that leads to that it's this incompressible, and the elasticity of it has to do with the um,
Potential energy.
rotationally elastic medium, which
Yes.
that's kind of that's really
It's rather like shear waves. If you have sort of like in an earthquake, you have solid earth, and you have shear waves. Well, there is a deformation in the solid, which is producing these shear waves. But I mean, you can have longitudinal waves as well. It really depends on the potential function.
we don't want longitudinal waves. So here's what um, I'm just going to kind of give you a little bit of a. I mean, this is kind of what I was able to find, which isn't much. Science in the 19th Century by René Taton. And this is 1966. This is a series. René Taton did a series of books. I think there are four of them on the history of science. And he covers a lot of ground. And he says, as for the ether, the mechanical properties with which it had to be endowed proved to be highly paradoxical. A perfect fluid at one moment, it had to be turned into a solid at the next. It was required to transmit transverse vibrations, and the absence in it of longitudinal waves was explained away either by endowing these waves with infinite velocity, total incompressibility in parentheses, or with zero velocity, perfect compressibility. Thomson adopted a hypothesis of MacCullagh. While the elasticity of solids results from their resistance to compression and distortion, the elasticity of the ether is a reaction to the rotation of its volume elements. I'm not sure if that makes it a little clearer, but we're talking about it's an elasticity. It's a what does he say here? It says the elasticity of the ether is a reaction to the rotation of its volume elements. Does that help anybody?
Let me tell you, it's a great pity for me that scientists before they didn't calculate what is the energy density or mass density of so-named ether. They speculated about solid state, perfect liquid, and all this stuff. And even in general relativity, we have this perfect liquid many times I told you about. You know, they didn't know the energy density of this cosmic medium. They tried to speculate around solid state, liquid, and all this stuff, but we have so rare field, cosmic medium that all these notions doesn't work at all, at all. That's why they wasted their time trying to explain some behavior of this cosmic medium without calculation its mass density, energy density at all. I don't know why it happens to people, why they were so blind, why they didn't calculate the most important part of it. What is the energy and mass density of this cosmic medium? And to expect even influence on the masses like our Earth, planets, against this medium, 1 proton per 4 cubic meters. This is the density of this medium. How it can resist to all these mechanical moments? I don't know. Maybe as I told you, 20 orders of magnitude less density than our air around. And we are calculating some resistance, standard resistance of this medium against movement of our mass objects in this cosmic medium. I don't understand it. Why people they didn't take a look at this very important parameter, density. I don't know. You cannot even introduce these notions, solid state, perfect fluid, and all this stuff. And even general relativity exists with perfect fluid. No, I can't believe it. How crazy our physics right now. Sorry for my
Okay,
emotions,
well,
as usual.
so you're saying, as I kind of gather from what you're saying, that this whole idea of an ether and creating ether models isn't really complete. It hasn't. It's still. It's was abandoned before it even became completely developed as a theory. That's kind of my interpretation of what you're saying. So,
Absolutely
in other
right. It was
words,
wasted time for people to calculate, to do all these calculations. There's so many experiments to prove that we have this ether by movement of our Earth and all this stuff. So many speculations, so many arguments. Oh my goodness. Instead of take a look what kind of medium you have around, and that's it. And forget about all this solid states, perfect fluid, and all this stuff. You cannot introduce these even points, these characteristics of the cosmic medium about them. And yes, I don't know, guys. Sometimes I don't understand why physicists they forgot about these genius people. A lot of genius people I revealed for myself, and I'm so happy about it because I'm trying to recover all these guys and to introduce to a new physics everything from the beginning. Lissage theory of gravity instead of this geometric general relativity. It's geometry. It's a theory. It doesn't matter. It doesn't work at all for me. No, we forgot MacCullagh, but we remember right now 400 years plus even already for Einstein general relativity. It doesn't work at all. At all. You can't fluid. There is nothing. I don't know, man.
okay, we don't have much time left here. Got 2 minutes. Um, I'm not sure we're going to have enough discussion here to proceed for another 100 for 2 other sessions. Um, anybody have any issues that they would like to discuss in the next session?
It's a very good question. Guys, I like our conversations. Let's go with something else. Maybe somebody will ask good questions, and we'll try to answer these questions. Let's do something about it. Like I don't want. I'm in vacation right now. I'm not in California, in Nevada right now. But I'm so happy to be part of our conversation today about MacCullagh. Maybe we have some other issues to talk about it. Maybe somebody can raise this question, and we can talk about it, because to me, it's our conversations with our group. It's not good for us, man. It's not fair even.
Okay.
Hello, Vladimir. I asked you some questions on the chat. Can you look at them?
Yes. No, on the chat I don't see anything right now, man.
No, there
But
are some
can you
questions there.
talk in English, in words, not in your chat? What your question about? And maybe if it
Okay.
will be enough, we will talk to the next session.
Okay. The question
Well,
I asked, I
discussion.
think the
Listen,
session is up
Akimbo,
now.
Akimbo's been working on this ether theory issue for a number of years, and we've been having a back and forth. So I suggested he might want to join us today. So I don't see the chat at all.
Yes, I don't see it either.
Oh,
That's
I
why,
see the chat now. I turned off the share screen. It's down at the bottom. There's a chat. Can you
Yeah, less
probably,
than a minute.
yeah, okay. So why don't we discuss this in the next session?
Let's talk next session. Don't be in a hurry. We have plenty time. I
Okay.
agree
All
with
right.
you, absolutely. Maybe you recover your camera. I want to see you, man. I do like talk to you face to face.
I don't know why my camera is not working. It's I started it. I had a difficulty getting Zoom to start. I just don't. I don't know. Okay, so we got a less than a minute. Anyway, Akimbo, restart the computer. Okay, here we are at the second session. Okay, so is the recording working? Okay, looks like it. Okay.
Yeah, I'm recording.
Okay, good. So we're talking about MacCullagh's ether model, and as it relates to Vladimir's cosmology, and I guess Akimbo had some questions, so I guess we'll let him ask some questions, and so go ahead.
Okay, yes. I have some questions for Vladimir. I am interested in MacCullagh's aether too. I've done some work on that, but let me go straight to my questions. We are all agreed that the aether model that is preferred will carry transverse waves. That implies that it must have shear elasticity. Now, there are two ways of getting rid of longitudinal waves. One way is to give the medium an infinite bulk elasticity. In that way, it becomes incompressible and will be unable to carry longitudinal waves. Now, my question for Vladimir is this. Is it impossible to design a material that will have zero bulk elasticity, which also makes it impossible for it to carry longitudinal waves? That's on that question. The other one, you mentioned about energy density. I don't know whether you are familiar with the concept of omega in cosmology, which is given a value of 1 and commonly described as making the universe to be flat. If you follow the logic of that, I think you can get to something similar to the energy density that you are looking for. Those are the 2 points I want to make.
As for me, let me ask you this first question. Is it possible to create, to develop, to manufacture this medium I doubt, because there
Okay.
is no really
Yes.
standard medium as we have around our life, in our life. That's
Yeah.
it. Forget it.
Yeah.
As
You
for
are
the
correct.
omega,
Earlier on, you mentioned that we should not consider the ether as being of the same nature as our matter substances that we are familiar with. So if a supreme designer, a supreme being, omniscient designer, wants to design a material that will not be able to carry longitudinal waves, do you think it's beyond the capacity of this supreme material designer to design a medium that has zero bulk elasticity?
yes, I told you that one more time, I will repeat. In this cosmic medium, we have 1 proton per 4 cubic meters. What kind of material, what kind of volume of this material we should create to develop, to develop such a medium accordingly to MacCullagh theory? I don't know. It's, we should take maybe space of the solar system and all this stuff. I doubt that our human beings, we can do such medium. The second very important question about this omega. Everybody talking about omega, everybody talking about the relative issues. What is the relative energy density of cosmic medium against this, 1? And 1 is a critical energy density. And nobody talking about the absolute value of it. Yes, even in my model, you have this energy density of cosmic medium equals to 2/3 of this omega. Omega is 2/3, means 66, 67% of this critical energy density. But critical energy density is so low that you cannot even imagine it. It's only cosmic medium what we have around. We cannot do any other material in close to the cosmic medium. Simple like this. That's why, why people, they didn't calculate the absolute way. By the way, they calculated in some other theories, they calculate this critical energy density or talking about and all this stuff in some values, but nobody saw the real numbers. This is how they missed it. I don't know.
Okay,
That's
I
why,
agree with you, Vladimir.
and what is
It will be
important,
difficult.
let me finish.
Okay.
MacCullagh
Okay.
told very genius words that if it will be revealed, this cosmic medium, it will be so unique, so different from the materials around us. And he was absolutely
Exactly.
right. He was genius,
That's
guys.
true.
Simple like
That's
this.
true.
I was
That's
so happy to reveal him, to find him. It was very difficult for me. I didn't know anything about Marco. It was something, happy moment of me to find him and to be happy. Boy, how many people? John Mitchell, remember I talked about this, another genius physicist, about these binary systems. He opened them 180 years ago, and only later, 180 years ago, at last, we found this, binary system in our solar system. I don't know why physics went a wrong direction. Why they forgot about these genius people, genius physicists. Oh, they forgot it, and that's it. And they developed some geometry, some general relativity, some equations, very complicated. We don't need them at all. We don't need it because they don't work.
Okay, I think we
That's
should
why.
give some
And
credit as
Maxwell
well
equations,
to
it's really MacCullagh's equations for gravity-magnetism, electromagnetism. Everything depends what you will put in a notion charge. Charge may be mass, charge may be electric, might be another charge. I don't know. But at least electromagnetism and gravity-magnetism, they charges, and that's it. But the form of these Maxwell equations is the same as MacCullagh opened in his theory. This
okay.
was the most important part of
Okay,
it.
can you
Okay.
let Akimbo
Let me
talk?
say two. Let me say two things. One is that we should not leave Lord Kelvin out of those who we have to credit with a medium that cannot carry longitudinal waves. You can't leave Lord Kelvin out of it. He even brought the name negative compressibility. I can send you a quote from his Baltimore lecture, maybe later on.
Okay.
The second thing I want to ask you is, let us forget about the possibility or impossibility of creating a medium that has zero bulk elasticity. Now, let us imagine it can be created. How do you think that medium will look like? Forget about whether it's difficult to create. How do you think that medium will look like?
You're talking about gravity now?
No, I'm talking of a medium that has zero bulk elasticity.
That has zero
For one, zero bulk
elasticity.
Bulk elasticity.
Well, yeah.
That's a ELASTICT. Yeah.
Is zero bulk elasticity
I think for one,
as infinite modulus?
Yes, modulus. Yes, black modulus of bulk modulus of elasticity.
Okay, thank you.
Yeah. So for one, such a medium cannot carry longitudinal waves.
Correct.
Second, such a medium will be transparent and will not be able to resist motion in a straight line. At least those two properties you must expect from such a medium. I don't know whether Vladimir agrees with that.
I'm sorry, my English may be not so good, and that's why I don't understand the question. What I cannot answer. Maybe Harry, he's a very good translator between Ukrainian guy and you in English. Harry, try to understand this question and try to answer this question, because I'm very sorry. If you have some references, you can send me references. I can read English for so many years. That's why no problems with it. I can answer you in letters. It's not a big deal. But to understand each other, it's not our native English language. Yeah. I'm very sorry, man. That's why please do something for better explanation of what you're talking about.
I think you were asking about resistance to linear motion through the medium. Is that correct? That was what I thought.
Yes, okay. That's it. You are correct.
So you're asking, like, how does something move through this rotationally elastic medium of MacCullagh? How do particles move through it? I think that's what you're trying to.
I'll put, because of my accent, I'll put my question in the chat.
So, guys, we don't need to move these particles, if I understood correct, without any force on them. It's absolutely wrong. Many times I told you, there is no rotation of our volumes. There is rotational elasticity. You want to explain your gravitational waves. Then you have some waves, you have some forces, and the response of your cosmic medium with rotational and potential energy. That's it, simple like this. You don't think about this rotation from the very beginning. But what is important? If there is no any elasticity in our medium, solid, liquid, and all this cosmic medium, you cannot transmit any wavelengths or waves. You cannot transmit anything. You must have. This is the main crazy guy who told that we don't need any medium to transmit electromagnetic waves. Absolutely wrong. Without medium, any transmission cannot be. So it's simple like this.
I'm interested to know.
We have a different potential energy.
If I may ask, I'm interested to know. You say that it should really be MacCullagh's equations. Now, I'm interested to know what form his equations took. I mean, he was using standard analysis, but as we well know, what are called Maxwell's equations were never written by Maxwell at all. He used quaternions, and it's the Heaviside form of Gibbs functions and so on. So, what form are the original equations that MacCullagh put down? Do you know that, Vladimir?
No, of course not. And what is important, even Maxwell equations, we don't know. We know Maxwell equations, calculated and introduced to us another genius physicist 100 years ago. Not Maxwell's, not MacCullagh. And many times, even in my papers, I told analogous to. Analogous means we don't know. And only good mathematicians, they can compare what we have right now. Gravitomagnetism, it was the same story, the same guy. He developed gravitomagnetism, electromagnetism, and MacCullagh theory inside of it.
And who is that you're talking about?
My goodness, oh, I will tell you right now, man. I'm sorry. I'm sorry. I will. Oh,
It's some Russian
introduce
scientist.
gravitomagnetism. Let me take a look maybe on Wikipedia and you will see immediately his name. Oh my goodness. I'm very sorry. Let me try to do something
All right,
about it.
thank you. You're not talking about Wesley by any means, no.
Yeah, no.
J.P. Wesley.
Oh, it was another very genius physicist, and we forgot about him. One sec. Who introduced them, and you will see immediately.
Another one of my fellow countrymen, no doubt. They're all coming up.
Well, that's another, when his name came up when James was talking about O'Reilly, his name kept coming up. And I realized I didn't really know that much about MacCullagh, and I'd seen his name, but I didn't really know anything about, other than what I'd read in Whitaker's book, which I didn't really understand.
Okay, I found it, guys. Oliver Heaviside in
I said that.
1893.
Yes, I mentioned Oliver Heaviside. Yes.
Yes, he's exactly the guy. He introduced all the equations what we have right now in our hands. It's only him. He could translate all these MacCullagh's, Maxwell equations, gravitomagnetism in one package. Oliver Heaviside.
Yes.
Sorry for some delay because I forgot. It's not good, but sometimes it happens.
Okay. All right. So Akimbo's question that he put in the chat, do you agree that a medium having zero bulk modulus of elasticity cannot carry longitudinal waves? Question. I think the answer to that is yes. Do you agree that such a medium will not resist rectilinear motion? That's his question. Let's forget how to create it. So his additional question is, do you agree that such a medium will not resist rectilinear motion?
I don't know. I'm following the equations, analogous to Maxwell equations in my mind. And that's it, what I have right now. I used only this idea. I didn't develop this maybe idea. I am not even Lord Kelvin. He was, by the way, he was a genius physicist too. I know him in some other, branches of physics. I like him. I love him. He was a father of physics at his time. He was the highest Olympus mountain for physicists all around. That's why, I'm so sorry. It's not my point right now to develop something in particular. If somebody has in mind some theories based on MacCullagh's theory, I will be more than happy about it. What is important? All this, even, the elasticity of what we have right now in liquids and solid states, for me, we cannot apply this approach to the cosmic medium because they are absolutely wrong. Absolutely wrong. They're so rare field our medium that we cannot introduce this interaction between these masses very far away from each other. We cannot introduce even these small notions. How we can apply theories developed for one object or very, very dense the rare field, theory for MacCullagh, for ether. I don't know. It's totally different story. That's why even to ask this question, can we do this? Can we do that? No, we cannot, because we don't have in our hands the medium we are talking about.
Okay, you're breaking up a bit and you disappeared. Am I frozen or is it
We
Vladimir?
have
No, Vladimir is frozen. Can't see you, so don't
You were
know if you're
frozen.
frozen.
Now he's gone. Oh
Yeah.
gosh.
disappeared.
Okay,
I'm
I'm
present.
kind of
I'm present. Guys, even in my vacation, guys, even I'm in this conversation. I'm very
okay. Okay, you're back. You were gone
what
there
else
for
we
a
have to
while.
discuss?
Okay, I'm not sure what happened there. There was some kind of freezing and interrupting of what you were saying. Let me ask you this question. Do you see, as I see the issue, I've got this book here by Zedediah Buchwald, From Maxwell to Microphysics. And it's very difficult to read, but basically what he's really saying is kind of in a nutshell, he's talking about how the ether theories and Maxwell's ether didn't really carry on past the 19th century. And so Einstein sort of just cuts off um, this whole thread or way of doing physics. It just terminates with Einstein. And then Einstein says there's no ether, there's no medium, it's all geometry. And so then they've jumped on it's all geometry with some, the geometry is warped by the presence of mass and energy in space. And so it all becomes these geometric equations. And I guess what my understanding of what you're saying, Vladimir, is that they sort of shouldn't have done that. They should have continued on with the MacCullagh approach, the ether approach, rather than just throwing it away and turning everything into geometry. Is that correct? What I'm understanding?
absolutely correct. It is absolutely correct. Even in my papers, I put this, quote, don't throw away baby with the bath water. It's exactly what Einstein done in his general relativity. As I told you, in cosmic medium, we have two-thirds, 67% of the total energy of our world. And we threw it away. Come on, guys. How we could do it, I don't know.
Well,
That's why,
I'm puzzled by the fact that when they show you these diagrams, and I think we talked about this when I was talking about the Lambda CDM model, something like 26%, 5% of the universe is actual matter that we can touch, and 26% is dark matter, whatever that is. And the rest of it, 68, 70% is dark energy, which nobody can even tell me what it is. And now they're saying that, well, the dark energy seems to be changing, and it looks like they've kind of like, it's not really clear that they even know what they're talking about, and they're trying to explain that their observations don't really fit with the model anymore because the dark energy doesn't seem to be constant. But to me, a bigger issue is why only 5% of the universe is actual real matter, and the rest of it is something that we don't know anything about. To me, that's kind of like, what?
You're absolutely right, man. It's crazy to develop physics on 5% of the matter. All the rest we don't know anything about. It's for me, it doesn't work at all. It's crazy. Let me tell you, you're absolutely right. They don't know anything about dark matter. They didn't even talk about where it came from. We don't know generation of this dark matter. What is the mechanism? Who is doing it? Why? And so on. We know nothing about dark energy. It's absolutely wrong. And why? Because physicists they don't exist right now. Only mathematicians. They have these equations and they're trying to accommodate the theory to the experiments. This is the most important part of it. Who is the egg? Who is the chicken? Simple like this. Physicists, first of all, should talk about experiments and then try to develop model according to experiments. They're doing on the contrary. They have mathematics, they have the equation, and now let's accommodate experiments to this theory. Come on, guys. It's absolutely crazy. It's absolutely wrong. It's against physics because physics is well known experimental science, not theoretical science. And what is important, as I told you, 2/3 of our energy of overall world is cosmic medium. The next very important point, instead of dark energy, I introduced, different mechanism of our so-named expansion. There is no expansion. There is no expansion in the fourth dimension. We cannot feel it, but we can see stretching. We can see that one object moving out from us. That's it. And we don't understand why they introduce dark energy. And I introduced stretching of our hypersphere as the result of the expansion of center of our nuclear of the world in the fourth spatial dimension. You see, there is no issue with dark energy. We don't have any issues. And what is important? They had this inflation theory. For 10 to the minus 34 seconds, you have your spreading to 93 billion light years. What kind of, expansion you have right now? What kind of inflation? In my model, you can name it like inflation, but it's a continuous inflation. All the time, there is a stretching, there is a movement, one object against another one, accordingly to hypersphere model. Simple like this. And you don't need any dark energy at all, even talk about it. About dark matter, as I told you, yes, dark matter is a very important issue. It's well known right now. We have binary systems, binary stars, binary galaxies, and all this stuff. We cannot walk without dark matter. But nobody told where you took it from. You introduce one parameter, 26, 27%. Who cares for them? They're accommodating all these numbers accordingly to their theories. But theory wrong, then these numbers is wrong. Simple like this. As for our standard material, our ordinary matter, according to, one more time, to my model, 4.8% of our standard or ordinary matter, it's our plasma, intergalactic plasma. It's a real protons, electrons, and so on and so on. And only 2.4% of our ordinary matter inside of the macro objects. It's a very important numbers, and I calculated them directly from my model. But what is important? Why so small? Because ordinary matter is the result of self-annihilation of dark matter particles, so named. Harry, thank you so much for pushing me to put a new name for dark matter. Universe created matter, universe created particles. It's my contemporary definitions of this dark matter, because it's not dark at all. It can have these X-rays, it can have all these gamma rays and all this stuff. It's not dark. It's irradiating energy in a different wavelengths, and that's it. Simple like this. That's why even only 2.4%. And by the way, according to their theory and calculations about all the masses of all the galaxies around, they calculated this number about 2%. They calculated it, that ordinary matter is only in macro objects. It's only 2%. I agree, but I put this number, 2.4%, and I know based on very simple mathematics of classical physics. Classical physics. I don't need general relativity, special relativity. I don't need all this stuff, guys. That's why you see, one more time, there is a cosmic medium. There is, in cosmic medium, we have this, this, I don't know. Microwave background radiation. We have this plasma we have this far infrared background radiation. We have so much stuff inside of our vacuum, or I don't know what they have in general relativity. I have no clue. And this is experimental results. It's not my imaginations. And I'm trying to explain the existing experimental results. I'm from the beginning by nature experimentalist, but I'm thinking about experiments and I'm trying in my mind to find the explanation for experimental results. You see, it's simple like this. And theory right now, I mean physicists, they are mathematicians only. They don't know anything about physics. They don't know anything about experiments. They're trying to develop some new approach to their equations and to find some solutions. But so many problems right now, especially right now with GWST telescope, so many, we have well-developed galaxies 300 even less million light years a million years after the big so-named Big Bang. What does it mean, even Big Bang? Nobody knows. I don't know. I'm so excited and I'm so emotional because we exist with you in a crazy world of physics right now. Crazy. It's not physics at all. It is mathematics, and some mathematicians, they put these borders around the equation and they don't want to put anybody inside of this circle. That's why I'm outsider for them.
Well, I think it's a bit more complicated now in that what you have is uh, they're creating these sophisticated computer models based on their mathematical equations. And so they're looking at the universe through the lens, if you will, of their computer models. Okay. And then the question in my mind is, what are these computer models? And I suspect they're very complicated and that's why they have 100 authors on these papers, because I suspect that these computer models are made by various groups. You got a group at one university that builds a computer model, and another group in another university that builds another part of the computer model, and then I guess they try to mash them together. This part's not really clear to me exactly how all these models have to be big. They have to be run on sophisticated computer systems. And how they're doing that, I haven't really seen much. You hear a lot of stuff about, they discovered this and they discovered that, but you don't hear much about how they're actually calculating these things and how the model is actually created.
You're absolutely right. Let me tell you that in general relativity, right now they have some over 20 different parameters, over 20. Of course, they cannot, accommodate these 20 parameters with any experimental results without computers. Simple like this. Because equations are wrong. They introduce this equation and they put all these 20 parameters to play with them and to find the best matching between experiments and their equations. Simple like this. This is exactly the value of this programs and all this stuff. Do you know that even this our black hole inside of our galaxy, they calculate it by computers. They have so many parameters. They try to do this and this. And what is important, even the angle of rotation of our core of our galaxy have a totally different direction that in reality. How you can take it? I don't know, man. I don't know. No,
Well,
I'm in a crazy world right now. I don't know. Do you have this feeling? I have a feeling we are crazy guys. We have a crazy physics. I don't know how to understand even. I don't know. That's why don't even try to understand. Harry, it's my recommendation to you, all this physics, computer physics. Forget about it. When you have, in my university, somebody told, very smart guy, if you have more than 3 parameters, you can adjust any curve on your plane, on your blackboard, and all this stuff. 3 parameters, it's enough. But if you have over 20 parameters, it's so simple. But you must use computer because there is no way. And what is the most important, guys? In my model, I have standard two parameters only, alpha and Q, that's it. But they're standard, they are dimensionless without any changes. They have theory, and there is no standard parameters except this speed of light, general relativity, G, I don't know, gravitational constant, and C. That's it, what they have. But all the rest physics based on flexible parameters. What kind of theory we have? Theory must be based on something stable, fund, something very stable. They change all this time, all the time. What kind of flexible theory we have? Instead of standard Maxwell equation, you have a standard, theory. You have standard equations. I don't know. It's against, one more time, against common sense even. What kind of theory we have based on flexible parameters? Please tell me 20 parameters. Why you took so many? What's it nature, mother nature you have with 20 flexible parameters? How come? It cannot be. I don't know. Sorry for my emotions. You touched very sensitive strains in my soul, I'm sorry.
Well, with this still, you still have the issue of that the distance measure is based on redshift, and so
Get about redshift. It's a bullshit.
That's an assumption that they're dependent upon in all their models. And
let me remind you one more time, analogous. It's a very simple. One more time. It's because of Big Bang model. We have our solar system. We have planets moving around. And all the time we have changes in our distance against all the other planets. Some of them moving to us, some of them going out of us. That's why you have your blue shifted planets, you have your red shifted planets. But it doesn't mean anything. The distance to them doesn't depend on this parameter. It depends on our gravitational force between sun and these planets. That's it. And the same story in my model. There is no Big Bang. There is some kind of combination of different huge superclusters. There may be more than 1,000, but it's some quantity, 1,000, maybe 10,000, not more superclusters. And we are moving with our galaxy like a planet in our solar system around the center of superclusters. That's why all these galaxies around have the same story into our Milky Way galaxy, some of them out. What the meaning of this Z, blue shifted, red shifted, and all this stuff? There is no meaning. There is no meaning. Forget about it. And what is important, many times, I told you, 8,500 blue shifted galaxies named some physicists, very good one, by the way, Gupta. He published these results. Let me ask you, the very close galaxy to us, Andromeda, it's moving to us. It's against the Big Bang model immediately, because all of them should go out. And even this, very close galaxy going to us, and we're talking about what the time will be when they will collide. Good, we will not survive this time. We cannot check it. We cannot prove it. But what is important? There are 8,500 galaxies blue shifted. How to explain them? And you can easily explain in my analog of planetary system in our solar system. And we have our central supercluster, Laniakea supercluster, and all the galaxies going around a supercluster center. That's it. Analog of our solar system, very good works for the whole our world. But they don't know about it. They know nothing about it. They're talking about Z and they don't know how to explain. And what is important, by the way, I read the last paper about the Z. You know that Hubble constant depends on the place they're looking for. In one place, this Hubble constant higher, in another one lower, and so on and so on. How come universe managed by the Hubble constant that varies from the place to place? What kind of model we have? What kind of theory we have with a modified even Hubble constant? But in my parameter, there is a Hubble parameter, and there is a very Standard, in relation to cosmological time, it's a reverse of cosmological time. This is a Hubble constant. It's not a constant parameter, but there is a variation of this parameter in time, and that's it. And it doesn't depend on the place of this, interaction between different galaxies and so on and so on. What is important? Let me tell you, cosmic medium, it's not only medium, it's the basis for all the physics, because all the physics, all these equations, laws, depends on cosmic medium only. Macro objects, 2.4% only, like a particle in a liquid. You have your water and you have very small particles, dust particles, and so on. This is exactly the model of our world. That's why 2.4% of our macro objects, you cannot build physics based on this 2.4% of your energy density of your world. You must go to cosmic medium, and all the equations depends on cosmic medium only, because these particles, they're very small. Even galaxies, they're very small. Simple like this, guys. That's why you can use our standard physical laws right now. Many times I told you right now, you don't need to do anything. But with variation of these parameters, gravitational parameter, Hubble parameter, they vary with cosmological time. That's it. But the form of these equations, the value of these equations, all this, I don't know, everything what we have in our hands stays the same. Because it's based on cosmic medium. Einstein threw the away. There is no cosmic medium. There is a vacuum. That's it. You see, the basis of the whole physics depends on a cosmic medium. Nevertheless, we threw it away, and that's it. Simple as it. And now we're playing with this geometry, with these equations, with all this stuff. By the way,
we got less than a minute now.
Well, it's good. It's good. Let's finish for today, because I put too much emotions. Sorry, guys, because I cannot take it already. I'm tired of all these bullshits around us.
All right. Okay. Well, I thank you for talking to us. So, do we have anybody that has any questions that we can any comments? We don't seem to have much energy here for. I don't know whether Akimbo is still with us or not. His camera is off, so I don't know whether he has. Okay, so we don't have that many people. Oh, here comes Akimbo. I guess I'm kind of curious as to what Akimbo is going to say. Because I know that you're interested in cosmology and you have been for years, and I think you have your own kind of cosmology viewpoint. Is that correct?
Yes, that's true.
And I wonder whether you've been keeping up with all these changes that they've been making since the JWST. Have you been keeping up with that?
Well, I've been hearing about them, but I've been skeptical. Let me use that word. I've been skeptical about claims that have been made.
Yeah, I think they want to hold on to their model. But they seem to be finding lots of stuff that they weren't thinking that they were going to find.
Yes.
I guess they
but
thought they were going to.
There's something in their model they have not, they still hold on to, which I agree with. They still keep on saying the universe is flat. What does this mean?
Yeah, good question. I talked a little bit about this issue about what you brought up with the Omega, and I don't really know that much about it, and so it's kind of a little bit out of my depth.
What Omega means is that the Schwarzschild radius, if that's the correct way of pronouncing it, the amount of matter and energy in the Schwarzschild radius is enough to balance, to keep it as a black hole. Let me put it. I think it's 2gm over RC squared is equals to 1. That's what the universe being flat. That's what it means. G is the gravitational constant. M is the amount of matter in the universe all over the cosmic radius, and C squared. So C is a constant, G is a constant. Then you can play around with the M and the R.
Right. And so I talked about this a couple of months ago, the critical density parameter, and that makes the universe flat. Now,
yes, that's it.
What's not clear to me is what happens when you add the dark energy and the dark matter. And are they making the universe flat even though they've added these two things in?
Yes, those are the things when all added up make the universe flat.
Okay, so
when
they're
all
saying
added up, yes.
So what we have is dark energy and dark matter, which is the majority of everything, and it's a lot of stuff that seems like, you know, it's just there to make the model work. It doesn't. It's not really
the dark matter, dark energy, plus the normal matter. All these things make up the M in the Schwarzschild radius. All make up the M.
Right. So things are there that are in the model that they don't really know what they are, so they call them dark.
Well, you might say that.
Okay.
I don't know if you've noticed this very much, but I've been rather surprised at the or almost volte-face of Roger Penrose. I mean, he seemed in the past to be rather orthodox, and now, probably since the JWST, he seems to be taking quite an unorthodox view of things and questioning things that would have been accepted before. I don't know if any of you have noticed that.
Well, he's got this model that he's promoting, and I forgot the name of it. I talked about that, where the universe recurs. Conformal cosmology, I think he calls it. And so he's kind of got an axe to grind, but he's already got a Nobel Prize, and so he doesn't. I guess he can't offend anybody. They can't kick him out of the university for not agreeing and going along. So
although it's a good thing, not many people who have earned Nobel Prizes or become very eminent do end up at the end of their lives as dissidents. I mean, there are exceptions, like maybe Herbert Dingle and so on, but
he's not. I see your point. You know, it's like when you get a Nobel Prize, you've been ushered into the club, and I guess it's not considered good form to say the club is based. The rules of the club are wrong and need to be changed.
Yes, that's right.
Okay. All right. I see that Vladimir has left us and James is here. Jim, you seem to be late today.
Yeah, I overslept, man. I guess I was more tired than I thought I was, and I just woke up a few minutes ago. I'm sorry that I missed the first part of this session. I was looking forward to it.
Okay, well, I guess you can see it in the recording.
Yeah, I'll check that out definitely.
I guess the issue that this raises for me, this idea that there's a medium, there's a cosmic medium. Vladimir refers to it, calls it the cosmic medium. It's not real clear to me exactly what he means by that. I think he means that that's the underlying structure. And from what we were discussing earlier, he sort of objects to the idea that the underlying structure is geometry, which is the Einstein view. So we have geometry, space, this empty space, and it has a geometry. And so relativity sort of tries to describe the universe based on that the geometry of the universe is affected by the mass that it contains. And so now that we have dark energy and dark matter, then we have two other things that affect how the universe behaves as a whole. Okay, so the geometry is changed by these dark energy, dark matter things. Okay, but in your case, you're saying you're making the argument that the structure starts at the very small, as opposed to the Einstein view that it starts with the very big. Correct?
Who's saying that, Jim?
I'm talking to Jim.
Yeah.
Jim's theory about this binary mechanics, where he has space divided up into cells and actions occur according to the rules of binary mechanics, motion and these other things.
Yes,
And
Harry.
that's a completely. So I'm wondering, have you thought about the idea of there being some kind of an ether in your model? You don't.
Well, I'm a little hesitant to comment since I don't know what happened before and what people said before. But yes, Harry, in binary mechanics, there is an absolute reference frame which can be said to be the ether, and it's a combination, I guess you might say, of the structure submitted by binary mechanics, that space, in fact, has a structure, and that the content are these one states, so that yes, binary mechanics defines in its own way an ether.
Okay, now you're using a term differently than that. I saw this video days ago where a guy started talking about the ether, and and he never really defined what he means by this word, which I think is kind of tricky. Vladimir is sort of using a different word. He's I think using what he says called cosmic medium.
Well, the problem with Vladimir, again, I'm hesitant to comment since I don't know what was said before today, but Vladimir, I think, has a tendency just to define things and not give a really a mathematical structure. In my opinion, the only way to determine if one theory is different from another is to compare the mathematics between the two.
Okay, well, what I'm trying to understand is, in your view, there would be no cosmic medium. There's just these cells of the binary mechanics that you've created. You've divided up space into little parts, and time is divided up into discrete parts. And then time moves forward discretely, and actions occur from moving to one cell of space to another cell.
That's correct. And that's what you're describing is full quantization. And it's like a night and day difference in the fundamental assumption, where we are dropping the assumption that space and time are continuous. And further, I've been arguing since the beginning, and more recently trying to emphasize this, that as the outdated quantum mechanics and others attempt to define or calculate things at very microscopic scales, they're going to experience a lot of error, because they're assuming that space and time are continuous, and therefore a position, they can say that a particle or an object is at a certain position, which actually doesn't exist, because the only valid positions would be integer multiples of the length constant, the primary length constant, if you catch what I'm saying. The same
Right.
way.
Well, that's a little more. The question I'm asking is the issue that how do electromagnetic waves move in binary mechanics? That's kind of really what I'm trying to get at.
Well, there are
hold on. What we were talking about, the MacCullagh ether, it was a kind of an attempt to explain light waves. Okay, and the idea is that there's the medium allows for light waves to be transmitted by this elasticity that occurs in the medium, that's not like a compression, or it's a reaction against rotational. It's a reaction against rotational stress. Okay, that's kind of confusing. But anyway, so the question in my mind is, how in your model do EM waves progress through space?
Well, by the motion of one states from one position to another. And
yeah, but that doesn't really, that's just a description of the motion, and it doesn't describe how the wave progresses and is originated and goes forward as a wave of energy.
Well, the whole idea of a wave is actually a concept which would involve a collection of quanta and an analysis at that level. Like, right. For example, we could say that in the football stadium, when people do a wave, we can start to analyze that sort of at a macroscopic level, if you will. But really, if we look closely, we see that it's individual people standing up and sitting down in a certain pattern, which produces what, when we sit back and look at it, appears to be a wave. So that basically binary mechanics is asserting that we do have space, and we do have stuff in it. And so that everyone, I hope, would agree at least with that. And if we can agree with that, we can move forward. But when we talk about, how do we get the wave and so forth? Well, we could go interview all the people in the stadium and ask them, what instructions they had as to when they should stand up and sit down. And so that when we stand back and look at it, it looks like a wave is crossing the spectators in the grandstands of the stadium.
Okay, I understand all this, but the question is, are the boxes full of something, or are they not full of something? All these little boxes, or do they have something in them, or are they all empty? So are they all full, or are they all empty?
Well, there's sort of two ways to approach that question. It's a good question. I think that the next frontier is to analyze what parts or subcomponents these boxes, as you call them, and that's fine with me, have in order to do what they appear to do, so that we can say what parts do they have. At the level of analysis of full quantization, though, what they contain is something or nothing, one state or zero state. And so we're not going to argue about what is the stuff that we have in the universe. We're just going to say that we have some stuff here, and we're going to call it a one state. We're going to admit that we don't know what that stuff is at perhaps a more fundamental level. and move from there. By the way, welcome, Okimbo Oho. If I pronounced the name right, I hadn't seen you before. Welcome.
Yes. Hello, James. I have
Hi.
a question for you. Yes. Is there
Okay.
elasticity in binary mechanics?
Well, again, elasticity
binary mechanics?
is again a sort of a macro concept, and like for example, I'm doing an analysis now of the Hall effect to demonstrate the Hall effect using the binary mechanics simulator. And so what I have to do is run the simulator, take the output file, and look at the positions of charge elements, which are fractional charge elements in binary mechanics, and analyze where they're moving, and is there a Hall effect? And in other words, a transverse voltage developing with reference to the direction of charge motion, so that you see how we can start with the fully quantized events of charges actually moving, and then analyze whether or not there a transverse voltage, which we call the Hall effect, in fact occurs. It seems that it does occur, and we're working on a paper on exactly that right now. So that when you talk about is there elasticity, well, define to me what you mean by elasticity, and we can then look for elasticity in events that the binary mechanics simulator produces. As a theory of everything, any known phenomena should be analyzable using the binary mechanics simulator, or at least the equations of binary mechanics, recognizing the limitations of the software that I've developed thus far. In other words, that software developed over years, adding features to do various tests, so that maybe there's not the feature in there to look at what you call elasticity yet, and or maybe there is. So that, we could email back and forth about this, and you can see what you can tell me what your definition of elasticity is, and I might be able to guide you as to where in the binary mechanics simulator you could look for it and study it.
Okay, thank you. Thank you.
Thank you.
Yeah.
I'm sorry I overslept, because these sessions by Harry have been really stimulating and very, very interesting.
Yeah.
I've learned a lot.
Okay, well, I was really trying to get at to what Akimbo was asking, and that is, there's the Iver-Cat solution to the problem, which I have a lot of sympathy for, but it sort of brings up a sort of a fundamental issue. It kind of jumps over some fundamental questions. He says that electromagnetic wave is a structure. You have an electric field and a magnetic field at right angles, and it travels at sea. Okay, so he sort of avoids the problem of whether there needs to be a medium or not by essentially creating the postulate that the electromagnetic wave travels at sea. And it would seem to me that in your model, Jim, that's kind of what you have to assume as well. It's just there's no explanation of why waves travel at sea, EM waves travel at sea. It's just that they do in your model. Is that correct?
There's no explanation. Let's see what that actually means.
Okay, let me say, okay, in the ether model, the idea is that you explain the velocity c by the parameters of the medium of the ether. The physical parameters of the ether define the velocity c. Now, in Iver-Cat's model, he doesn't concern himself with that. He says the waves travel at sea. That's as a postulate. Do you see what I'm driving at? So my question is,
aren't in the first alternative that you just mentioned, aren't those parameters of the vacuum the permittivity and permeability both empirically derived values?
Well, in the modern theory, there is no ether. And so those values essentially go into the definitions of what an electric field and what a magnetic field are. And that's a bit more.
But the actual value of those parameters is this is something I'm trying to fully understand. It seems to me that the values of those parameters actually come from the empirical observations of, say, folks, like Coulomb's law and the magnetism. Let's see, who was that did the permeability?
Yes, you're correct. But essentially what it boils down to is you can set up what's called an electrostatic system of units, where you define the unit of electricity by the force between charges. And then you can set up an electromagnetic system of units where you look at a force exerted by a current. Okay. And then it turns out that once you have these two systems of units, it turns out that they're related by the speed of light c. And that led Maxwell to his brilliant conclusion that light travels at velocity c. Okay, that's basically the essence of it. And then later they divided the constants up into permittivity and permittivity by the Georgi system. And Georgi, that system was resisted a while until they agreed on the SI system of units. So the permittivity and the permittivity are, in a way, essentially a way to rationalize the systems of units. It's not really clear that they're actually physical things that really exist.
In fact, in the SI system, I think they say, look, let's define mu naught over 4 pi as exactly equal to 10 to the minus 7. That's it. And then we'll find out empirically what epsilon naught is.
It's a definition. So these parameters, so the question, that's a bigger problem. The issue in my mind is in binary mechanics, my question that I'm trying to get at is, it seems to me you'd have to sort of do the cat assumption, which is that electromagnetic interactions occur at C, as a postulate for your system of binary mechanics.
Well, again, electromagnetic interactions, what exactly are you talking about there?
Well, I'm just asking you the question as to how do you deal with motion of electromagnetic waves? Okay, through your binary mechanics medium, which you say is absolute. So
everything reduces down to the motion of quanta and how they move, and the time development equations of binary mechanics specify that. And in experiments using the simulator, if I shoot quanta as a light signal, you notice that what I'm saying just right now, I'm saying that whatever it is that you want to talk about is either involve quanta. I mean, it does involve quanta doing something or another. And so if we shoot quanta into one side of the simulation and wait until see when they arrive at the other side, or some of them arrive at least at the other side of the simulation, we can then calculate the light speed. But what is the quote unquote light? It's quanta moving in the spot cube spatial lattice structure postulated by binary mechanics. And so it all starts with a basic assumption, which is not that space and time is continuous, but rather that space-time, and in fact energy as well, are quantized, which is entirely different than everything in science basically before that.
Okay, but I'm still asking. I'm still asking what
Press me. I'm in the process of waking up.
velocity.
So press me.
I'm still trying to understand what defines the velocity of light. Okay, so in Einstein's version of it, that's just a postulate. The velocity of light is c, and it's by definition that's their fundamental primary postulate. The velocity of light is c, so everything hinges upon that definition that they have.
Well, okay, what defines the velocity of light is the equations of motion of binary mechanics. And so that you could almost flip the discussion backwards and say, why don't we get the speed of light from Newton's laws of motion, so to speak? Well, they're incomplete. That's why. If you have laws of motion that are complete, you get the values for all of the secondary constants, like Planck's constant, the speed of light, electric charge.
But you're not really answering what my question is.
Okay.
My question is, how does your system relate to the Ivercat? Ivercat says my postulate is that light travels at c because I say so. That's a postulate.
That's not my postulate. No.
Well, I'm asking, what is your postulate?
That we have developed basically the time development equations of binary mechanics, which are the laws of motion in a fully quantized environment. And when we apply those laws of motion, we get certain values, such as the speed of light. And there's no other equations for motion that I'm aware of that produces that result.
Okay, so that's not really very satisfactory to me, but I understand where you're coming from.
Well, isn't that? I appreciate this back and forth here, Harry, a great deal. So let's keep going there. If equations that produce observed results are not enough, if that's the word you use, enough for you, I would say that you're looking for something beyond science, perhaps. Are you not?
No, that's not. I'm perfectly happy with Ivercat's claim, okay, and primarily because he just takes it as a postulate and he doesn't try to justify it. Okay.
Okay. Well, I'm not happy with that.
And you seem to be sort of going down below to justify the velocity of light by your previous assumptions in binary mechanics. And it's not clear to me how those assumptions produce the velocity of light.
I've written several papers on measuring the unidirectional speed of light, and one can look at those and critique those, and mistakes were made or they weren't made, but in the end, we have equations of motion which produce the value. Now, Ivercats, I can't really comment officially, if you will, about it, because that name is new to me today. I've never heard that name before, nor read what his thinking is. But it sounds to me, the way you're portraying it, if I may, Harry, in all humility, it sounds like Ivercats is just given up. In other words, one of the biggest questions of science today is why the values of the so-called fundamental constants have the measured values that they do. So we have a collection of observations, and it seems like Ivercat is simply saying, let's just ignore the fact that we don't know why these values are the values that we measure, and proceed from there. This is what Einstein did in general.
Yeah, he's doing that. You're correct.
That's not science. That's abdication of responsibility.
That's a different issue. Okay, and he's talking about something different. So my question, so you're claiming now you're saying that there's some kind of fundamental constants that your theory can explain. Now, you didn't bring this up before.
Well,
And
that's primary constant.
your fundamental constants, as I understand it, is not based on the speed of light. Your fundamental constant is something different. And that I know you talked about this before. You use alpha, I think. Is this not correct?
Well, actually, I reversed
Fine structure constant.
To get the fundamental constants in my video and recent paper, how to derive the primary and secondary constants, were reverse engineered from the values of the secondary constants, which are the speed of light, Planck's constant, electric charge, and so forth, electron mass, and so forth. So,
so your theory is derived from the velocity of light. So you're, by working backwards, by reverse engineering, the speed of light is already in your theory. Is that?
It's used as input data.
All right.
In other words, that's what science is all about. You have observations, or what we call input data in this case, the so-called measured speed of light, and that is something to be accounted for. And that's, it seems that without binary mechanics, you just have to accept that these are somehow that we're just going to stop doing science when it comes to these values. We're not going to ask, why is Planck's constant the value that we measure? We're not going to ask. That's verboten, taboo, not permitted to ask. But we're going to use these measured values as if we don't have to explain or understand them, but we're going to use them as inputs to our grand, wonderful theories like general relativity. I just looked at the field equations, and guess what's in those equations? The speed of light, c.
Yeah, that's what I've been saying, yes. We've been talking about this. So the real issue, the point I was really trying to get at is the theory. What we were talking about before was MacCullagh's ether theory. So what they were doing in the 19th century was they were postulating the existence of an ether thing, and then from that attempting to derive how the universe worked based on this postulate of ethereal substance. And they didn't really have a whole lot of success with that. And it would appear that Einstein came along and said, here's my theory. I don't have to explain things based on this postulate of the existence of an ether. I say it doesn't exist, or it's superfluous. And I'll just assume the speed of light is a constant and build my theory based on that. And that's basically the where we stand in physics today. Okay.
Well, I would agree with your summary. I would definitely agree with your summary there, that basically people have said, I can't win the ball game, so I'm just going to assume I'm a loser and proceed from there. I'm not even going to try. And,
well, that's essentially what happened around the turn of the 19th, at the end of the 19th century. There was a big shift. They gave up on the ether paradigm and switched to vacuum space, empty space, vacuum space. And structure is related to the geometry of the space as affected by masses that exist in it. And so there's no medium, there's no physical structure of space. There's no something that makes the universe the universe. It's just geometry. And
right.
The structure of space is just mathematical geometry.
And so what happens when you just take one of the primary constants, that for length, the moment you quantize that, you have an entirely different playing field to work on, because a lot of the notions that are derived from continuous space-time theory don't apply anymore. And so that's maybe one of the more radical features of binary mechanics. And so that basically we can say that the primary constants of binary mechanics, the three values for energy, length, and time, replace the Planck scale values that everyone or many people seem to refer to. Those are completely irrelevant. They are simply combinations of unexplained values, the secondary constants or so-called fundamental constants, and as such, they are as unexplained as the unexplained constants from which the Planck scale values are computed, which are people just juggling with the units and saying, well, you know, and in a totally logically inconsistent way, because they say, for example,
all right, we're coming up on the end here.
Okay.
Well,
I'm sorry I missed the first part. I overslept. That's what happens.
Does anybody have any comments or questions about real quick before we end? Okay, I appreciate everybody coming by and participating this morning. I'm not sure that we clarified the issue about MacCullagh's ether, his ether theory, but I was certainly curious to find out what its physics was about. So sorry you missed that. So I guess we'll be ending here in 30 seconds or so. So any final comments?
Roger, I look forward to your email about posting the video for today. I'm sorry I missed the first part.
All right.
Okay. Cheers.
Kembo, did you learn anything today that was helpful for you?
Yes, I did. Yes, I did.
Well, you're welcome to come back. And if you want, I'll put you on the distribution list.